Hello. Good evening, everyone.
Good afternoon.
Oh, it's noon there.
Yeah,
Okay.
how the word.
Okay. Hello everyone, dear authors and invited guests. Welcome to the technical session 8B. Myself, Aarti Mohan, and I would be moderating this session. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you all to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of this conference is being held in a hybrid mode, and the virtual event is being held through Zoom today, that is 22nd February 2024. I hope you will enjoy this knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 2 minutes for the question and answer session round. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any sort of query or update, you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair of this session, Professor Zornitsa. She is an associate professor at the University of National and World Economy. Her specialization is in innovation management, technology management and digitalization, and business management information system. With her extensive experience and expertise in innovation management and digitalization. It's an immense pleasure to welcome you here with us, ma'am.
Hello, everyone. It's my pleasure to be here.
I would like to introduce the other session chair, Dr. Nitesh Bhatt. He's a professor at Nirma University and the chairperson of Information Management Area at Institute of Management, Nirma University, Ahmedabad. He has more than 22 years of experience in academia, corporate training, and research. His research domain are e-governance, e-commerce, and enterprise applications. It's my pleasure to have you on board with us, sir.
Thank you, Aarti, and I also welcome Dr. Jornitsa. And my best wishes to all the participants. We would like to learn from your wonderful research. And once the presentation is over, as Aarti mentioned, some time is earmarked for question and answer. So I request other participants also to ask questions. And if they would like to add some value based on their past research or some insights, we will welcome that also. Aarti.
Yes, sir. Definitely. We can have this as an open session for everyone to ask the questions and interactive, make it more interactive as well. So it's a nice thing. Ma'am, you have any remarks for our participants? Opening remarks?
I'm just opening the floor for any questions and productive environment. Let's all of us learn from the research of the others. And after this session, I hope everyone will benefit in addition to and extend our knowledge in these different areas. And why not we collaborate in the future somehow between all of us participants in this session. Good luck, everyone.
Yeah, thank you, ma'am. Moving on to the presentation, first presentation, I would like to invite Sanjoy Sanyal to present his paper on a method to secure digital content by synthesizing digital twin using dynamic color mapping. Dear presenter, could you please proceed with your presentation?
Yes, of course. The video. Can you hear me? Hello?
I have one quick remark to make. While we expect everyone who is present here to turn on their camera, but in case you do not do that, at least the presenter should turn on their camera. We would like to see you also.
Okay. Okay, perfect. That's not a problem. Okay, can you see me? Okay, can you hear me and see me? Hello?
Yeah, we can hear you, but we can't see you.
Yeah, we can just hear you.
Oh, sorry.
Yes, now
Put on
it's
my video, but okay. Oh, perfect. Yeah, sorry, the internet connection is not that great, but yeah, try to do with it. Yeah. So let's start. So our topic of discussion is on a method to secure digital content by synthesizing a digital twin using dynamic color mapping. So a storage of sensitive data in the cloud invokes questions on cybersecurity and safety. This holds true for a variety of cloud category cloud deployments, just public clouds, distributed clouds, and hybrid clouds. So in hybrid clouds, the chance of compromise of data increases due to the movement of data between public clouds, private clouds, and premise infrastructure.
so. Dear presenter, sorry to interrupt. We are not able to see your presentation.
Oh, sorry. Oh, I'm very sorry. I'm very sorry about that. I forgot to. Yeah. So I'll just I can't. Yeah. Can you all see my screen?
No, we can't. It's coming. It's coming.
Okay. Yeah. Sorry about the connection. Okay. Okay. I think I'm sharing it now. Oh, perfect. Yeah. Sorry about the connection. Um, so, like I was saying, so the storage of sensitive data in the cloud invokes questions on cybersecurity and safety. So this holds true for a variety of cloud deployments, such as public clouds, clouds or hybrid clouds. So in hybrid clouds, the chance of compromise of data increases because you have movement of data between public clouds, clouds, and on-premise infrastructures. So, sorry. Okay. So usually the contents of files is transformed into an undecipherable ciphertext and sent by a sender over a secure channel to the receiver, who then is able to decrypt the contents by using a secret key. So even if an attacker intercepts this ciphertext before it reaches the receiver, they won't be able to do anything unless they also possess the secret key. Yeah. So, can everyone hear me correctly? Sorry about that. Okay. Yeah. So even if an attacker could retrieve this ciphertext, they won't be able to do anything unless they also possess the secret key. So there we land in two main types of encryption techniques: asymmetric cryptography and symmetric cryptography. So first, let's start with symmetric cryptography. So by using symmetric cryptography or symmetric encryption, the data is scrambled into so that data is scrambled so that it can't be understood by anyone who doesn't possess the secret key. So once this data is securely shared to the receiver who has this secret key, the algorithm reverses the changes made to the ciphertext that the receiver can see the message that was originally in the text. So the secret key that the sender and the receiver both use can either be a password or a code, or can be a random string of letters or numbers that have been generated by a secure random string generator. And so there are many types of symmetric cryptography algorithms, such as AES, DES, IDEA, and RC6. Now, for asymmetric cryptography, we have, it's also known as public-private key encryption because it uses two keys, a public key and a private key. While the public key is shared, the private key is kept private and used to decrypt the ciphertext. And this is why public-private key encryption is considered to be more secure. However, if this private key is compromised, then the attackers can decrypt the ciphertext. So one example of asymmetric cryptography, of an asymmetric cryptographic algorithm is RSA. In addition, we have two other types of cryptographic techniques, such as hybrid cryptography and zero-knowledge proofs. So for hybrid cryptography, it's basically a method that combines both asymmetric and symmetric cryptography. So the content is encrypted by using a symmetric key, which is then shared to the receiver via asymmetric cryptography. So once the receiver receives this symmetric public key, it can then decrypt it by using their asymmetric private key. And once that is done, they can use this asymmetric public key to decrypt their document, which is also sent to them. For zero-knowledge encryption, it is stored in such a manner that only the owner of the data can access it. And the system comprises of a proof system, which has two elements, a prover and a verifier. So in zero-knowledge proofs, the prover must prove to the verifier that the statement is correct without revealing the statement itself. However, with for example, asymmetric key cryptography, due to their computational complexity and the longer key sizes, they have a computational impact. Sorry, they have a performance impact, especially when processing real-time data and colossal chunks of data. So this can have a detrimental effect when dealing with time-sensitive data where latency is low. For symmetric cryptography, if the channel through which the symmetric key is shared is compromised, then the attackers can intercept the key and use it to decrypt the ciphertext that is being shared by the two users. To circumvent these limitations, the zero-knowledge model was introduced. However, with zero-knowledge proofs, there is a small probability that's called the sound error, with which a cheating attacker could a cheating prover could convince the verifier with a false statement. And in other words, we can say that zero-knowledge proofs are more stochastic than deterministic. However, even though there are methods to diminish this soundness error, one cannot eliminate the risk of compromise due to rogue provers. Thus, we come to a research question, which is, can we add an extra layer of security by synthesizing a digital twin using a color mapping algorithm that uses dynamic color tables? So let me introduce to the end-to-end architecture of this algorithm. So first, the original ASCII content is received by the digital twin generation algorithm. This algorithm then maps each ASCII character of the content to a pixel, which is then assigned a specific RGB level. So this is done by using a specific color mapping table. So in this manner, we formulate a color frame. And so based on the size of the ASCII content, many frames can be formulated. So at the end of this process, we get a lossless MPEG file, so which is a video file, and it is this MPEG file is the digital twin of our original content, so our ASCII content. So at the same time, the identity of the color table is encrypted using a public key and shared to the receiver end for who will be able to decrypt it by using the private key. So once that is done, the digital twin is encrypted by using a public key and conveyed to the receiver entity, which decrypts this digital twin using a private key, and then uses the identity of the color table that they received previously to get the original content from this digital twin that it got sent. Now let's talk about the digital twin creation process. So in this process, we have two elements, an encoder and a decoder. So the encoder creates the digital twin of the document by using a color mapping table with a specific number. And so with this table, it colors each pixel of the digital twin, which will be the video. And so this coloring is done by mapping each pixel to a character of the ASCII content. And this pixel is colored with the color that is associated in our color mapping table. to this ASCII character. So this coloring algorithm is explained in more detail in the paper. So once done, the encoder securely shares the digital twin to the decoder, and it also shares the table number to the decoder securely. So these are done through two different channels. And once the decoder receives the table number, it uses it to get the table that has the color mapping table that has been used by the encoder to create the digital twin. So once the decoder gets this table, it uses it to get the original content from the digital twin. So the advantage of this algorithm is that it randomly chooses one table among so 255 cubed minus 1 factorial over 255 cubed minus 1 minus 1 to 8 factorial possibilities. So this number is in the range of millions. So the detailed calculations with which we obtained this number here is explained in our paper. And so because the number of possible tables from which we could randomly choose one table is in the millions, it's very difficult for attackers to brute force our algorithm. Yeah, sorry. So it's as I was saying, it was very difficult for attackers to brute force our algorithm because of the millions of possible tables they could choose from. And so in the future, we need to assess the practicalities of our proposed algorithm. So practicalities in the implementation of our proposed algorithm by considering the space that should be required to hold all our millions of possible color tables. And also we should try to consider we should try to consider the computing power required to create our digital twin and also to decode it. Also, we could test the potency of our algorithm by using ethical. So that was all from my side. Thank you very much for listening. Any questions? Okay, can you hear me first?
Yes, please. You can stop your presentation. Dr. Zornitsa, you can ask a question.
Yeah, I have a question. So how does the dynamic nature of your digital twin and color mapping algorithm impact computational resources? Because we all know that nowadays, with especially the last year, with all these advancements and in AI for personal and business use, the computational resources are quite limited at the moment. So what would be, how do you see the scalability of that method?
So the thing is that we haven't really considered it so that's in our future scope. So yeah, I think what we do is maybe consider how to store all our millions of color mapping tables. So yeah, actually the thing is that this number is too huge to be stored. So maybe, for example, when it's applied in an industrial scale, maybe cloud providers could maybe not propose all the to guarantee security and that kind of stuff. But I mean that's maybe in the future scope we need to maybe work on that part.
Thank you very much. That would be interesting research, though. The next one.
Srini Joy.
Yeah.
You are currently based at which country? Where are you based? Which country?
In Luxembourg.
Luxembourg, okay.
Okay.
One question.
Belgium, yeah, Belgium.
Yeah, right.
Yeah, the border with Luxembourg.
One question and one observation. Based on my limited understanding, I'm yet to come across any digital twin for a digital content. Generally, digital twinning is a concept which is applicable for a physical infrastructure. maybe airport, right? Or a plant or a manufacturing setup, something like that, or city map or something like that. This is first time I am hearing. Probably I'm maybe short of my research.
Yeah.
That is first observation. However, my question to you is, when we say digital twinning and the model which you proposed, have you come across any other research or any other application where similar type of model where dynamic color mapping has been done is used for research this security purpose?
To my knowledge, I don't think so. I think, to my knowledge, I think we should be one of the first ones to propose it.
Okay.
So yeah.
Okay. So where else do you see the application of this dynamic color mapping apart from this cloud security?
So basically, it's to maybe like, so it's mostly to send documents. So it's, the thing is that the message are converted to videos. So it's so the advantage of this is, make it a bit more novel for hackers to people. So maybe you can for messaging, like, but that, the conditional uh, to decode and yes.
For me, your Kinijoy, your voice is cracking, but still I got a broad idea of what you are saying. So all the best to you. Thank you. We can go to the next presentation, please.
Thank you. Thank you so much for your presentation. Thank you, sir. Thank you, ma'am, for your questions as well. Moving on to the next presentation, I would like to invite Malvina to present her paper on a novel approach to regional e-government measurement, the case of Georgia. Dear presenter, could you please start with your presentation?
First of all, good evening from Georgia. So
Good
in some
evening.
countries we have like afternoon, so it's quite nighty here. So hope you can see my presentation. Can you?
Not yet, actually.
Not yet. Okay. Now it's better.
Yes, now it's visible.
So, okay, I will leave it here. So as we know, my presentation is about to find novel approach to the regional e-government measurement. And today we are going to talk about case of Georgia. So we know Georgia belongs to the category which is in a list that we are developing countries. So I think this topic is going to be quite interesting for the countries who are, and to the presenters who are from developing countries. So also we know that in academic world, a lot of attention has been given to the development of electronic government and assessing its impact, but commonly used framework called Electronic Government Development Index, created by the international organization, is to measure how electronic government is progressing. But this index was criticized by many authors. So in this study, we built on existing indices, and based on these indices, we are going to create new one. So our approach includes adding new context-specific element to make measuring electronic government more accurate at the regional level. The sub-criteria from our new model show positive connections, so that we thoroughly analyze, focused on Georgia, and we take a fresh regional perspective on electronic government development. So our paper also highlights the potential and the characteristic of the implementing and improving electronic government initiative at the regional level. So first we analyzed almost all existing indices which are trying to measure the development of the electronic governance. And in Georgia, there hasn't been much focus on studying of electronic governance. So especially, it's never happened at the regional level. By the way, in Georgia, we have 13 regions. So most research in Georgia academic literature revolves around open governance. So we don't pay attention on electronic governance. And from these 13 regions, only 6 of them are participating in open governance partnership. So I'm not going to talk about what does open governance partnership means and what are the area of open governance partnership, but I'm going to talk what about we were discussing in the article. The evolution of global indices such as digital divided index, electronic development index, you can see these indices. We first analyzed also network readiness index, which assess different aspects of ICT and electronic governance readiness index in countries. Additionally, the United Nations and East-West Institute have their own frameworks such as electronic governance development report and the Kyber readiness index also. So we can see in which areas these existed indices are spread, in how many countries are using, but these indices doesn't switch to all types of countries. So we had some research problem to find a suitable one for specific and for developing countries, and those are the main research problems. So the first one we can see that it can be limited regional data. So as we know, we were belonging until 1991 to the Soviet Union. So some not regional, at least some country data we don't have. Data at the regional level might not be easily available also, and the consistent across different regions also it doesn't exist. Most electronic government indices using national data, while they don't have regional data, but sometimes even we don't have countries as a country's data. So the second research problem is that electronic government initiatives are not preferably suited to the specific needs and the priorities of these regions. We mean that each region, we already said that we have 13 regions, and each region is developing in different way and in different priorities. And we say that almost half of them are not even not half of them, even less percentage of the regions of Georgia are participating in open governance initiatives. So to find a suitable index which will measure the development of electronic governance is quite difficult. And the third research problem is infrastructure. Digital infrastructure like internet connectivity varies between regions also. National indices might not consider these differences. So these remain problem existing during our research. So in a proposed index, we create new index and regional electronic development, we call it electronic government development index, to assess the development of the electronic government at the regional level. Firstly, we recognize the need to expand existing national level electronic government indices, and we suggest incorporating additional factors tailored to the regional context. The proposed index includes 10 categories covering aspects like infrastructure, digital literacy, service acceptability, citizen engagement, cybersecurity, and inclusivity. Some criteria we were taken from the indices which we were talking about this, but because we don't have a lot of time, I'm not going to talk which categories and which components we took from these indices, but mostly we are taken those criteria which were suitable to our region and to our countries. The criteria within each category are refined to ensure comprehensive evaluation. We authors emphasize the importance of considering the unique characteristics and the challenges of each region within the Georgia. As I told before, we had we created 10 categories, and article introduced a method to evaluate electronic governance progress in Georgia, which used not only 10 indicators, but these 10 indicators has with 26 specific criteria, and these criteria consider both established electronic government indicators and regional specific aspects. Also, we will weight the criteria, and weights are assigned to each indicator, but they cannot be adjusted based on the regional priorities. The suggested wage distribution aligns with the Georgian regional level electronic governance in assessment characteristics. So as we told, we had 10 categories, which includes regional infrastructure, digital literacy, regional service acceptability, regional digital inclusion, citizen engagement, cybersecurity, capacity, also regional data privacy, and regional open data, and regional digital inclusively as well. The highest overall score depends on the excelling in the regional infrastructure, and service acceptability considered the most critical indicators. The model emphasizes enhancing citizens' access to the digital services and focusing on electronic service availability to the agency of the website. During study and in a methodology, I have to add that we were studying not only website of each regions, but also we were taking the information public, we call it public information here in Georgia, which is supposed to be available not only by electronically on a web page, but by communicating with them in a physical way. So the ranking between by these categories in our 13 regions looks like that, and from this we can say that highest overall score depends on the excellence in the regional infrastructure and service acceptability, considering the most critical indicators. The model emphasizes enhancing citizen access to the digital services, focusing on electronic service availability on agency website. As a conclusion, we can say that some region in Georgia are in a front way, have succeeded in a different ways, they have succeeded in a different criteria, and it looks like that Tbilisi highlight the advanced electronic governance. Ajara has also strong performance, and by the way, I'm introducing Ajara right now, and Abkhazia need a lot of improvements. Another region like Juguria, Imereti, and Kakheti showed balanced development, and Tchetam-Tianeti and Rachalichhumi, also Kwemoswaneti, have growth opportunity, but needs to work. So overall assessment provides valuable insights for regional strategies and policy decisions, and promoting electronic governance and inclusivity in Georgia. Hope I have expressed all I wanted, and if you have some questions, I'm ready to answer. Can you hear?
Madam, you can take the lead, please.
Sorry?
If you have a question, you can take the lead first.
Yes, thank you very much. So my question, first of all, thank you very much for your presentation. It was very interesting for me, even though I'm not from a developing country, but I think such indexes are also very applicable also for developed countries. So my question is, because of the scalability of this index, what are the specific regional aspects that you incorporated in your index? and how, what are the
Okay.
plans for validating it in a real environment somehow, maybe for some regions for start, and then on a national level?
Okay, so in a model consequences, I have already talked that the criteria selected for this assessment not only align the established electronic government development indicators, but also take into account unique regional aspects. Before that, I say that some regions are already a member of the Open Governance Partnership, but those who are the members of the Open Governance Partnership, they are doing open governance mechanism and they are implementing these tools, but they don't recognize that it belongs to the open governance. Almost it can be recognized as the electronic governance. For example, when I talk that I'm from Fajara, Supreme Council of Autonomous Republic of Fajara, for example, the specific is that from our region, we have 6 municipalities, and from the 6 municipalities, most of them try to be a member of this Open Governance Partnership local members, but the specific of the other regions doesn't seem that they are strive to be a member of the OGP local members. Despite that, our legislative body is not a member of OGP locals, our achievement was paid a lot of attention, and in an Open Governance Partnership webpage, if you visit, you can see our achievements. So also in a specific criteria, we say that development of infrastructure, for example, infrastructure in our region is developed, and it's even shown in the indices that we are in a first place beside other regions. Also, infrastructure is also developed, for example, in a capital of our country. So that's why maybe in this region, Tbilisi took in the first the leading place. So in a specific criterion, we mean such aspects as motivation, infrastructure, possibility to take information on a web pages, availability of an electronic database on a web pages, also by communicated with them, the mechanism to be involved in a decision-making processes, and so on. For example, of the adaptability of the people
Malvina,
of disabilities to be involved with it. Oh, sorry. Thank you.
We got the spirit of your answer. One question, and I request you to please answer it very briefly. You have proposed a novel approach. Have you shared your findings with the government or policymakers? And what was their
Yes.
response?
Yes. For example, may I also bring this example from my region?
Very briefly, you can just provide the answer.
Okay.
What has been their response? What has been their response?
Even despite that we are not a member of the Open Governance Partnership, they are having action plans before even the membership. So when they are creating these action plans, they have concourse. How I can say, yes, they have concourse. You can take a part, and you can offer them how to improve electronic governance. If they like your idea, they will take it not only into consideration, but they will implement in their action plans.
I got it.
One of my idea was to.
Got it. So they are receptive to your idea. Thank you. All the best. All the best. Next presentation, please.
Thank you.
Thank you. Thank you so much for your presentation. Moving on to the next presentation. I would like to invite Mohammad Rauf to present his paper on Away from Theory, a cloud storage application with public key searchable encryption feature. Dear presenter, could you please proceed with your presentation?
Okay. Hello, everyone. Can you see my screen?
Yes, it's visible.
Okay. So this is a joint work First, I would like to say good evening, everyone. Nice to be here. And now I'm going to present my work, which is joint work between University of Electronic Science and Technology and Northumbria University of England. So we are going to start with introducing why we need why we present such an application. Then we follow by giving a high overview about the application, then more detailed, and we conclude the work. So first one, why we need such secure storage application. So we listed 4 reasons. Like we have the increasing frequency of sophisticated cyber threats pose significant risk to data security. Also, traditional storage solution may fall short in protecting sensitive information, and the reliance on cloud storage necessitates robust security measure. And finally, we should give users an organization safe solution to safeguard the valuable data. A typical overview of a workflow of the application would be the data owner will encrypt his data and send it to the cloud. Then authorized users can search using encrypted keyword that no one knows except for them. They pass it to the cloud server. The cloud server then return back the encrypted file. For the high overview, this is the big picture of the different submodules. We have an authentication module that will first check the user login. Then if it's authorized, then the user can perform the first phase, which is the upload phase, where he will attach a file and the keyword. The core will forward it to the file manager, where the file manager will encrypt and give back the encrypted file. Then the core will forward the keyword to the search encryption module, where he generate the encrypted index and forward it back to the core to save in the database, and the core will notify the user about the upload status. The second phase will be performing the search. As usual, the authentication module will check if the user is authorized. Then the user will proceed by giving the search keyword to the core. The core will you will forward it to the searchable encryption submodule to generate the trapdoor query and give back the trapdoor query result. The query will use it to look for the file in the database, and if found, it will forward it to the file manager, where it will decrypt and return back the search result to the user. This is a high overview code snippet of the different steps involved for this application. First, the user will check if the credentials are correct. Then we'll prompt the user for an action to take, either an upload, search, or upload or search. Then if an upload, the file manager will encrypt the file using iOS 256, generate the encrypted index, upload to the file manager will upload the encrypted file, and the searchable encryption will save the encrypted index, and we notify the user about the upload status and the save status. If the action is a search operation, then the search encryption will generate the trapdoor query. Then we use this query to retrieve the matching file. If the matching file is found, then we decrypt and return back the encrypted file. For more detailed overview, we have, as we said, different submodules. We start with the auth submodule that will check the user registration and authentication and give access or authorize the user to manipulate the data. So in this one is just simple use case where the user provide the username and the password. The auth submodule will validate the username and the password and check them in the database and notify the user by giving status either invalid credential or give the access to the user. The next submodule will be the file manager submodule, which manages file operations like encrypting data, uploading and downloading files. The user will upload the file. File manager will encrypt and forward the encrypted data to the core to save it on the cloud and to the database, and will notify the user about the upload status. The second phase will be requesting a file to download. The file manager will ask the core, which then the core will retrieve from the database and forward back the encrypted file. If found, the file manager decrypts and forward the decrypted file back to the user. The next module is the searchable encryption, which enables encrypted data search by generating secure indexes and protect the keyword, the search keyword. The user will upload the keyword to the search encryption module. The encryption module generates the encrypted index and forward it to the core. The core then save it to the database and notify the user about the upload status. The second phase is the search, where the user uses the search keyword to look for a file. The search encrypt will generate the trapdoor query and forward it to the core. The core will execute this search query and notify the user about the search result. For a conclusion, some of the key features that the proposed application provides are that we use iOS 256 as a mechanism for encrypting the files and storing them in the database. We use the searchable encryption primitive that facilitates secure search over data without a need of decryption. First, we offer access control, which means that only authorized users are permitted to do such action, and we also add some login for logging the user activities and data access history. Some future works that we are considering is, instead of just using simple username and password, we would like to use multi-factor authentication, which will help improve and secure the application more. We are also intending to explore the possibility of incorporating this technology with the blockchain technology to mitigate single points failure, especially when it comes to storing the blockchain of a decentralized storage. And finally, quantum cryptography, which will offer robust security layer to ensure that the encryption mechanism stay ahead of potential decryption threats. This is the end of my talk, and thank you. If you have any question, I will be happy to answer.
Yeah, I have one actually. Thank you very much for your presentation. So my question is related to, you mentioned that you've developed a user-friendly solution. So
Yeah.
how this user-friendliness has been validated by users or by designers? And my second, but it's all related question is, have you involved users in the phase of the development of the solution?
This one was like a work lab. To answer the first question about you, like you said, user-friendly, we make it a clone of Dropbox, like or Google Cloud. The interface is similar to the Dropbox interface, so it will be like more like the interface will be similar to that one. So if you used previously any other cloud solution service, you will find that the application is you can adapt fast, like when you're using the new application. For your second question, this one was a work lab, so the reviews are from my lab mates, so it's not a real product. So I don't know if this is answer your question or
It was close to innovation. Thank you very
yeah.
much.
You're welcome.
All the best, Mohammed. Thank you.
Yeah, thank you.
We can have the
Thank you.
next presentation, please.
Yes, sir. Thank you. Thank you so much for your presentation. Moving on to the next
welcome.
presentation. I would like to invite Vijay Sundra to present his paper on cognitive complexity analysis and optimization tool for Java. Dear presenter, could you please proceed with your presentation?
Yeah, sure. I hope I'm audible and you can see my presentation. Yeah, thank you.
Yes.
So, good evening, ladies and gentlemen. I am Akit Vijayasundara from Sri Lanka Institute of Information Technology. So today I'll be presenting my research on cognitive complexity analysis and optimization tool for Java. So moving on. So what exactly is cognitive complexity relative to software development? That is how difficult to understand a code and mentally process a piece of code and fully understand it. So a highly cognitively complex software code is just like this tangled ball of wires I have given in the picture. So if I tell you to select the start and the end of a wire on a particular color, it will be nearly impossible. So in the same way, the software developers will face a very hard time if your code is very complex to understand the business logic, and also they will be very, less confident in making any changes for the code. So what exactly are the problems that we have identified which are in the market? So mostly in the software engineering teams, they tend to neglect this cognitive complexity in the early stages. But as the code bases will grow, these as well, the directly proportional, the cognitive complexity will too grow with the code bases. Thus, it will reduce the maintainability drastically. So this will diminish the developer confidence in modifying the existing code, and also it will increase the time spent in deciphering the code. So these things will result in slower development and increased bugs, because if the developer changes do some changes without understanding the proper implementation of the code, then he'll do some changing somewhere else, and there will be another bug popping out from somewhere other parts. So, and also obviously reduced in maintainability. And with this, now we are clear that we need to control the cognitive complexity when it comes to a code. And most importantly, the Tom DiMacro famously said that you cannot control what you cannot measure. So there have been number of researchers which is done to measure cognitive complexity. They have put forward many matrices like CB measure, ICB, so on and so forth. But it is not feasible for us to calculate the cognitive complexity of a large code base manually. So we have a requirement for a automated tool to do that task. And also there are many limitations in the existing solutions. We do have existing solutions, but there are a lot of limitations as of inconsistency, and they are using very outdated matrices, and the user friendliness is also being a problem in the existing solutions. So we'll talk about a bit of the key features that we are trying to give with this tool. So in the first place, we are trying to handle the automated metric calculation using different matrices. These matrices I'll be talking in the next slide. And also the visual representation of the metrics results using graphs and charts. And also moreover, in our system, we'll highlight the areas of the code sections where the cognitive complexity is high. And also taking a step further, we have connected our system with the large language model, where we can optimize the code for the user by using a large language model. So that is one of the novel approaches that we took here. And also, okay, so in the methodology, when selecting what kind of metrics we should use in our system, we adhere to the IEEE standard of software quality matrix methodology. So first, we established our quality requirements that we are trying to address. So there we identified 3 quality requirements: cognitive complexity, code maintainability, and the code size, which will affect the quality of the code. So the next step for us was to identify the quality matrices which are used for these requirements. So to measure the cognitive complexity, we used improved CB measure. So normally CB measure is just using 4 factors to come up with the cognitive complexity, but in the improved CB measure, we are using 8 factors to come up with the cognitive complexity. So that is more of an accurate answer that we'll be getting. And also pretty much a straightforward approach. Then thereafter implementing these quality matrices and analyzing the result and validating these quality matrices and the testing phase. So if we used quite a bit of tools for this one, I guess everyone is familiar with these tools, React.js, Chart.js for showing using graphs. So Python was our main backend language that we have used. And one notable thing is we used Java package. Why we use this one is to expedite our development process, where if we use now Java package, it wholly had pre-built grammar files, Java grammar files. So I did not need to build that from ground up. And also we used large language model APIs to connect with a large language model so that we can get the code optimized automatically. So this is a snapshot of the system diagram. So in the top, we are going to input the source code through our input model. And then we can go in 2 ways, whether you can go with code parsing and do the analysis, or we can directly send the code to the large language model, and we can use AI to make our code optimized. So if we go through the code parsing section, so here we will pass the code and create an abstract syntax tree. So we can iterate through that. And so in the analyzer module, we'll be calculating the ICB calculations, the LOC, the lines of code, and the maintainability index. And also, so thereafter we have the data storage section where we are going to store the data metrics, and also we can store any miscellaneous data if we are going to store like past results or pieces of code if we want to store them, and then any user data for authentication and everything. So that is in the data storage model. And the output is 3 form. You can either you can have the calculated results and the graphical representations, and also if you choose to go with then the AI optimized code, of course you will get the LLM optimized code too. So if we went to discuss about the results of our system, so we tested this with the real world code bases obtained from our university students, fellow students, and from there we observed 90% accuracy in our results. So here, if we enter this type of code to a system, the real one will be the ICB value will be 70. In our tool, we observed it is giving like nearly 65 with us. And the maintainability index, the real maintainability index for this kind of code was 86%, 86. But our tool gave us 80. And the lines of code identified in the real one was 8. And that one we had 100%, where our one also identified as 8. Yeah, so that's about the analysis, and also to give an example about the large language model optimized one. So in the left side, you can see this is an unoptimized code here. So if we send this through our APIs to the large language models, and then here we can get the optimized code where, yeah, you can see it in the right. Yeah, that's pretty much it for the conclusion. So our tool successfully automates the computation of the cognitive complexity and maintainability. And this will contribute to large amount of cost savings and time savings when it comes to development, and mainly in the maintenance phase, where you spend lots of time and budget. And there are notable possible further developments to support other languages. So what I have built here is supporting only Java. So we can extend this for Python and everything. And also furthermore, some researchers can do up to like identifying some threshold values. So like if some code is passing this amount of threshold value, okay, then that is a highly complex one, you should keep under this threshold value, and so on. So such kind of future developments can be done on this. And that's pretty much it. Thank you for listening. And if there are any questions, I'll be happy to answer.
Thank you very much. Actually, in one of the last sentences, you actually answered one of my questions about extending this algorithm for another languages. So I'll just ask Akit another one. So how does this tool integrate with existing software development environments? And have you received any feedback from Java-based Java developers so far?
Yes. Yeah, of course. So what we did here is like you can integrate this seamlessly with the software development environments. Like that too has to be done with some other upgrades that we have not done here. For when you deploy the code for your central repositories, we can send it through our system, and then we can analyze and give them output at the building phase. So that's how we can integrate this one seamlessly. Or otherwise, we can simply use this as a tool time to time to check your cognitive complexity. And for your second question was what kind of feedback that we have got from the Java developers. Yes, of course, these two we have tested with our the other colleagues in the university. We have very positive things where they could, especially when it comes to our optimized code, they can easily optimize the cognitive complexity rather than just other tools where they just give the matrices. Our one will also optimize the code automatically. So that kind of feedback is that what we got.
Thank you very much.
Thank you.
Akit,
Thank you.
Akit, small question, and please respond briefly. Why Java only? Why did you select Java?
Yeah, so frankly, I choose Java because I'm kind of biased with Java, so I went with Java. Yeah, that is why actually I went with Java, but this can be used for other languages also. You can expand this. That is a further development. And also one factor was deciding was the time limitation that I had to do this one. So because of those two factors only, I went with Java.
Okay, so now that you already done it for Java, can you rethink in terms of your algorithm, how you can develop it further, that model?
Yeah. So basically then a bit of changes should be done where we have to take out the Java-lang package that I have used. And then when we should develop the grammar files for each and every programming language, JavaScript, Python, or anything programming language that we are trying to support, we have to develop the grammar files. Then that's also, as long as we have the grammar files, then we can create the abstract syntax tree. That's only the difference that we should do.
Thank you. All the best.
Thank you. Thank you. Welcome.
Thank you so much for your presentation. Moving on to the next presentation. I would like to invite Sini Virakne to present her paper on food talks, food ordering and delivering application for visually challenged. Dear presenter, could you please proceed with your presentation?
I hope you audible me. Can you?
Okay.
Yes, you are audible.
Good evening, everyone. I'm honored to have the opportunity to present to you today our research on food talk and innovative solution aimed at revolutionizing accessibility in online food ordering. Here are our authors. In our rapidly advancing digital age, the importance of accessibility and inclusivity cannot be overstated. Yet, despite the strides made in technology, many individuals, particularly those with visual impairments, still face significant barriers when it comes to accessing essential services like online food ordering. It is within this context that Food Talk emerged as a beacon of hope, offering a transformative solution to address these challenges head-on. So, throughout this presentation, we will deliver into the multifaceted objectives of our research. These include analyzing the functionality and user experience of Food Talk, assessing its impact on accessibility and inclusivity, evaluating its operational efficiency and gathering feedback for further enhancement. By exploring these aspects comprehensively, we aim to provide a holistic understanding of Food Talk's potential to reshape the landscape of online food ordering. So, before delving into our research findings, let's contextualize our study within the existing literature on accessibility in online food ordering. Visual impairment poses unique challenges in navigating digital interfaces, particularly in visually oriented platforms like online food ordering systems. Studies have highlighted the difficulties faced by visually impaired individuals in accessing and interacting with these platforms due to their heavy reliance on visual cues such as menus, images, and buttons. This reliance exacerbates feelings of exclusion and dependency, underscoring the urgent need for more inclusive approach. Existing solution, while attempting to address accessibility concerns, often fall short in providing a truly inclusive experience. For instance, Voice Foods and Here Foods have made strides in offering voice-enabled interfaces for visually impaired users, allowing them to navigate menus and place orders using voice commands. However, these solutions may lack comprehensive features such as real-time order tracking and delivery management, limiting their utility in addressing the diverse needs of users. Sidebites, another comparable system, aims to enhance dining experiences for visually impaired patrons by providing audio descriptions of restaurants, environments, and menus. While commendable, Sidebites may not fully address the challenges of online food ordering, where users rely heavily on digital interfaces rather than physical surroundings. In contrast, Food Talk stands out as a comprehensive solution that bridges the gap between accessibility and functionality in online food ordering by combining voice-enabled navigation with features such as real-time order tracking, delivery management, and user-friendly interfaces. Talk offers a holistic approach to accessibility that empowers visually impaired users while providing a seamless experience for all users. Through our comparative analysis, we aim to highlight the unique features and benefits of Food Talk, underscoring its potential to transform the online food ordering experience for visually impaired individuals and promote inclusively in digital platforms. Our research methodology is grounded in a systematic and rigorous approach. We began by familiarizing ourselves with the food talk system, followed by an assessment of its requirements. The development process involved crafting both front-end and back-end components with a focus on seamless integration of Alan AI for voice interactions. Through user testing and evaluation, we have rigorously assessed food talks effectiveness in meeting the diverse needs of users. Now let us delve into the core functionality of food talk from user registration to order tracking. Our system offers a myriad of features designed to enhance accessibility and user experience. By leveraging intuitive user interaction and sophisticated voice command recognition, Food Talk sets a new standard for inclusivity in online food ordering. Building upon the previous slide, explore Food Talk's functionality in greater detail. This includes its seamless user interaction, advanced voice commands recognition capabilities, and real-time order tracking features. Through these functionalities, Food Talk not only empowers visually impaired users, but also enhances the overall user experience for all users. So, user testing and evaluation, our research findings are underpinned by rigorous user testing and evaluation. Through comprehensive assessment of accuracy, efficiency, and user satisfaction, we have demonstrated Food Talk's effectiveness in meeting the diverse needs of our users. With impressive accuracy rates and high level of user satisfaction, Food Talk has proven to be a game changer in the realm of online food ordering. The impact of Food Talk on accessibility and user satisfaction is profound. By providing a seamless and inclusive experience, our system has the potential to transform the way visually impaired individuals engage with online food services. In the section, we will delve into our findings in greater detail, discussing the implications of Food Talk for accessibility, inclusivity, and user empowerment. In conclusion, Food Talk represents a significant milestone in the journey towards a more inclusive digital future. With its innovative approach to online food ordering, our system has the power to empower and enrich the lives of visually impaired individuals. As we look ahead, it is clear that solutions like Food Talk have the potential to bridge the digital divide and create a more accessible and inclusive world for it. So, before we conclude, I would like to acknowledge the contributions of our research and provide a list of references cited in our paper.
Thank you. Thank you.
Thank you for your attention.
Thank you. One small question from my side. You mentioned about testing this model or technology. So you tested this among how many sample?
We are tested this with our friends, not actually campus guys.
No, but were they visually impaired?
Yeah. We use for normal from normal people, we use a black coat to cover their eyes, and for we got some visually impaired peoples also, and
so Senevirna, when you say that normal people like us, and if they are stripped,
yeah,
right? Compare that. This is just my suggestion. Try with okay. What was the sample size of these people? Your friends who are actually not visually impaired?
It's 50 students and visually impaired. people, also 50 people.
50. So was there some difference in their feedback?
Yeah. Also, normal people can their do their things actually than visually impaired people, because they actually doing with online food delivering also, but visually impaired people
Wow.
in developing countries, like our developing countries, so they can't do such as things.
So again, let me continue. First of all, 50, even if there were 50 visually impaired, 50 is a relatively smaller size of sample. One. Second, try to make it more inclusive in terms of having both genders, right? And from different age group also. So as you say, they are your friends. So maybe they were, if I assume correctly, they may be in their 20s, early 20s rather. Their age may be 22, 23, 24, something like that. Try to include people who are in their 30s or 40s also. Because when you will develop this app or this technology, it will not be for youngsters like you or college going students. So different dimensions may come, and that will definitely benefit you to develop your model or app, and it will be much more enriched. So this is my suggestion. And Zornitsa, if you have anything, please.
First of all,
Thank you for
I
your
would say
suggestion.
amazing feedback really for the testers. And I would say that if you are trying to test this solution amongst elders, like 60, 70, 80 plus people, maybe you can reorientate your solution not for visually impaired users, but to elder people who are really
Actually.
biggest target audience. Yeah, very interesting, and I'm looking forward to this.
All
I
the best.
don't have any questions. All the best. Yeah, thank you.
Thank you for your suggestion.
Thank you. Thank you so much for your presentation. Thank you, ma'am. Thank you, sir, for your valuable questions. Moving on to the next presentation, I would like to invite Thierry to present his paper on hidden knowledge extraction for association rule mining technique based on the a priori and frequent pattern growth algorithm, a case study. Dear presenter, could you please proceed with your presentation?
Okay, do you catch it?
Yeah, we can see it.
Yes, we can see your
Okay,
presentation.
okay, it is coming, I think. Okay, thank you very much. So, my name is Dr. Saimana Thierry. I'm from University of Burundi. So, I'm gonna to present you the research topic, a hidden knowledge extraction for association rule mining technique based on the a priori and the frequent algorithm, a case study. So the agenda of the presentation where I'm gonna to present you first is the introduction. The second one is design and the implementation of the algorithms, and the third one is result and experiments, and the last one is conclusion. So as you can see, our research is on data mining. Okay, yeah, as you can see, data mining is used in various domains. As you can see, can be applied in machine learning, can be applied in the enforcement learning, and so on. So our target is to extract the knowledge from the huge database by using association rule mining technique. But To use that, we have to measure the performance of the result. By measuring the performance of the results, we have to use what we call support and the confidence. Means that you have to determine, yes, the confidence threshold and also the support. So we know the nowadays we have a huge amount of data. Okay, so means that to extract the useful information from the huge database, it is difficult, but there is some algorithm which we can use it to extract the useful information from the huge database. But some algorithms have some challenges, like when they are extracting the usual information, they scan many times the database, and they also may generate a lot of candidates from the database. So it means that here, for instance, the a priori algorithm has the problem of scanning more time the database. So now our objectives is to determine the performance characteristics of the algorithm of a priori and a frequent pattern graph. In this, on yes, on a small computer which is equipped with 80 GB of RAM. The second one, we have to design, yes, and they implement the algorithm by using the useful data structure. So according to the design and the implementation of our algorithm, here we want to see the methodology. The methodology we have used it. As you can see here, we have a retail market basket data. This is for input data. After the pre-processing phase, we have used the two algorithms, which I have already mentioned it. And at the end, means that we are extracting the useful frequent items. After the frequent items, we determine yes, or the whole association goals. So according to the result and the experimentary here, we have used, yes, we have used as I have already told you, I have used a computer equipped with 8 GB of RAM, and also we use the operating system which is Debian, and by implementing the algorithm, we have used what we call Anaconda Python. So our experiment is to determine the performance characteristics of the computer by extracting useful frequent items from database, from the supermarket database. As you can see here, I have tried to determine the problem which may have the computer. For instance, here we have extracted for one item. If it is one item set, means that here there is no problem with the memory. For the second item set, also it is there is no problem. For the third also there is no problem. But for the fourth items, you see that the memory, it is becoming very important. It's becoming very huge. Means that if you have this computer which is equipped with 8 GB, means that you have not a good result. So we need a supercomputer so that we can extract a useful information. So the result we have obtained here is the comparison of the two algorithms, a priori algorithm and the frequent pattern graph. As you can see, this is for running time. It is observed that a priori algorithm is used much time than than frequent patterns. And also we have done a comparison between the two algorithms by generating the association rules. As you can see here, by increasing what we call yes, confidence thread, but you can see by increasing doesn't have effect on the number of generated rules. You see the rules is still the same. The rules is still the same even though we increase the number of confidence threshold. So for conclusion here, what we have done is we have investigated the two algorithms. We have tried to design the two algorithms, and by using for data structure like linked list, that is the data structure we have used it. And the second one, we have to find out the frequent items, yes, generated from market basket data. So by conclusion, we have seen that yes, frequent pattern growth is good than the a priori algorithm. Thank you very much for listening to me. This is the end of my presentation. Thank you.
Thank you. So I'll just take the opportunity to ask a question. So have you identified the specific challenges or limitations that might affect the applicability of these algorithms in real world settings? The applicability.
Yes, because this one, the application of this algorithm, it is applied also in cybersecurity. Okay, in cybersecurity, yes, you can use them to extract, or to discover the cyber attack in computer network. This is the applicability of this algorithm.
Yeah.
Thank you. Thank you. All the best.
You're welcome. Okay.
Thank
Can I
you.
stop?
Thank you. Yeah, you
I don't know
can.
if we yeah, okay, thank you.
Thank you so much for your presentation. Moving on to the next presentation. We have Hank to present his paper on variational quantum algorithms in finance. Dear presenter, could you please proceed with your presentation?
Yes, I'm here. I'm ready to share my screen. And everyone hear my voice?
Yes,
good?
yes, please.
Oh, good. Just 1 second. Oh, it should be live now. Can you see it? All right. Oh, good. My name is Tim from the R&D Institute of Triton University in Vietnam. In this presentation, I'm discussing a project which was also published in this conference. The focus of the study is recent development in quantum machine learning and the application of them in finance. So what is the motivation behind this review? The quantum computer performance is predicted to surpass the traditional system soon, very soon, in terms of computational performance and capabilities. So it will significantly impact many industrial sectors in long term. We expect the financial sector to be one of the first to receive the advantage of this new technology. So here's the current progress on the quantum algorithm for the finance application, specifically focusing on the use case of machine learning, address it through machine learning. So let's talk about the VQA training. Firstly, the model, often be called the ANSAT, which is a trainable quantum circuit and responsible to process the information given the input data. The QC is a sequence of quantum gates, as you can see on the side, X, Y, and Z. The QC, each of them acts like a matrix multiplication and one measurement layer in here, which collapse the quantum state into the circuit into the classical information. All right. So traditionally, typically, VQA is a hybrid process, and we rely on the classical optimizer, on the classical computer, you can say, to find the combination of parameters for the circuit, which can be run on real quantum machine or a simulation. It will compute the cost function, and which then again could be fed into the optimizer and so on until the process converge at some minimum point. Illustrated in this figure. It's just a simulation, yeah. And let's now talk about how VQA contribute to the solving financing problems. All right, what we have here is a portfolio optimization using variational quantum eigensolver. The problem can be stated like so. For a number of assets within a period of trading time, we aim to find the optimum value of trading investment to maximize the return profit while minimizing the risk factor subject to some investment and other factors as well. It can be expressed as a constrained quadratic optimization problem, NP hard for traditional computer. At the same time, the problem can be solved by a variational quantum eigensolver provided by ICICT by IBM. The pipeline is follow, formulating the PO problem into the constrained quadratic optimization, and then from that, convert to the quadratic unconstrained binary optimization problem, and then converting it another time to a Hamiltonian problem. So it can be solved by a VQA. I will give the reference to this method later on. So by finding the Hamiltonian ground state, we can approximately compute the optimal solution. Note that it's only approximate, not like the solution is either optimal or suboptimal, depends on situations. Next thing, we have anomaly detection. Two ways. It is to find the data that is not follow the pattern of the data set, or just find the unusual data patterns. It can be used in many applications, such as data cleansing, surveillance, and fraud detection. This can be cause of unauthorized intrusion into a system or a faulty system. So two quantum machine learning algorithms can be used. In here are quantum support vector machine and quantum kernel component analysis. So the first one, it transforms the classical input, let's say into the quantum state, and act like a feature map that incorporates into the to the answer before to enhance the performance of many tasks, such as in here we have regressing or clustering. One novelty approach of this QSVM was presented for analyzing real payment dataset and improving the fraud detection task of a quantum classifier in terms of prediction accuracy. The second one, QKCA, is the implementation of kernel principal component analysis, often being called PCA for quantum computer. Much like the conventional PCA, is the unsupervised machine learning algorithm that is to extract most meaningful feature or component of the data. In here, in this context, we have quantum data, but anyway, allowing dimensionality reduction and data classification. The idea in here is to find the distance between the data point and the center of the training data. So to quantify how the data point is strayed away from the pattern, and if it's straight, let's say the distance is too much, and it can be a fraud. Next one, we have credit scoring. It is a machine learning problem that is predict future behavior given one past data, which of course can be formulated as a classification problem. The data set is For example, the past record of many factors such as salary, age, and economic indicators, several indicators. A novelty approach for this problem was studied in Singapore, a special class of hybrid classical network and quantum circuit, as we can see in here, was used as an ensemble model. So the classical nets and quantum nets can complement each other to produce a better result, capable of learning complex pattern within the credit score dataset collected across many Singaporean facilities. The result was, according to the author, promising, showing the quantum enhanced model can score higher than most classical counterparts.
We request you to please conclude.
Yep. You have a question? All right.
No, I'm requesting you to please conclude.
All right. So let's conclude with some insight. It is a new technology. VQA is a promising framework to implement ML algorithm onto a quantum machine. It has good promising for performance and allowing versatile customization, allowing many use cases within other industry, not limited to finance sector, but the finance sector would be the very first one to accept, to receive the advantage. And finally, the scalability. Today, quantum hardware is very limited, facing many constraints, but in the near future, the post-NISQ machine can allow to build large model. For example, let's say language model, large language model even, capable of learning more complex patterns. And that is the end of my presentation, and thank you for listening. Here, reference used in this talk, I have noted as a number. And yep, any question?
I don't think we have the time, but still, can you please shortly answer what are your expectations of short-term integration of quantum computing in the financial sector?
For the short term, let's say the vision about 3 or 5 years next, I am closely related to the IBM facility in Melbourne. So they are rolling out a series of quantum machines that are capable of delivering a couple of thousand qubits in the next years. So I was talking about scalability. It actually comes very near from now. So yep, very near. And the application is we can expect like to build like heavier machine, more like complex to process more data patterns, given the quantum advantage of the machine of the quantum machines already delivering, and they are proving it within last year, I think. Yeah, it's more promising.
Thank you very much.
Thank you and all the best.
Thank you.
Thank you. Thank you.
Shall I stop now? Any other questions?
No.
Thank you.
Thank you. Thank you so much for your presentation. This brings us to the end of our presentations. So, ma'am, you have any valuable remarks for all our participants? Could you please proceed with your valuable remarks?
Thank you very much for your participation in this conference. Amazing insights. I actually like the diversity of all the topics, and I really believe that we contributed to our own knowledge and future research directions, maybe. So I really liked one of the papers. So I'll just say a couple of words about the e-government measurement. Also, I found this index very useful for many other implementations as well. The digital twin in the first presentation was also a nice model. I was very curious about, and I'll be in the future very curious about the development of this tool for food ordering and delivering application for visually challenged people. So thank you very much to all the participants for your presentations. Good luck with your research, and I hope we can see in person very soon.
Thank you, ma'am. Thank you so much for your valuable and kind words. Sir, you have any valuable remarks?
Just 1 or 2 minutes maximum. 9th International Congress on ICT organized by GR Foundation. I'm grateful to GR Foundation, Dr. Amit and the entire team. Because this is an international congress, so I'm sure all of you can see there were 7 papers presented from 6 countries, right? So we have Belgian presentation, Georgia, China, 2 papers from Sri Lanka, 1 from Burundi, and finally 1 from Vietnam. So 7 papers from 6 countries. And if you look at 2 session chairs, myself, I am from India, and Dr. Zornitsa is from Bulgaria. So if
From
you
Bulgaria, if I may interrupt you, from Bulgaria, but I spent 2 months last year in Ahmedabad. So
okay, next time if you come to Ahmedabad, I'm free in Ahmedabad, do visit us.
Yeah.
I will
Thank you.
exchange. So in total, if you see in last 90 minutes, there is a representation from 9 countries, 8 countries, 8 countries. So that okay is really a wonderful achievement, and it's really truly an international congress. Another thing I would like to highlight, while this is a congress on ICT, but as Dr. Zornitsa was mentioning, there was technology, but more important is the application of technology. Like we were seeing this food talks, ICT for visually impaired people, or the last session, quantum computing, but for finance, right? And similarly, others also. So we could see. So the conclusion is that whichever technology we work for, but if we can find out some application for a specific segment or social strata, it will have much more wider appeal and application, that too in the long run. So best wishes to all the paper presenters, and our humble submission is that you keep on continuing with your research and make us proud, your country proud, and your organization proud. All the best. Thank you very much.
Thank you, sir. Thank you so much for your valuable words. So I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants to being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for all the support during this 9th version and all the previous 8 versions of the conference. We will be very happy to have you in the 10th version as well in 2025. All our presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have been forwarded to Springer. The publication would be live within 6 months. Kindly cooperate with the team of ICICT 2024. I would like to thank both of our session chairs for chairing the session. A token of appreciation to the chair on behalf of team ICICT 2024 and Global Knowledge Research Foundation and partners. Thank you, ma'am, and thank you, sir, for your valuable presence.
Thank you very much.
I would kindly request everyone to please switch on your camera so that we can have a quick snapshot of the virtual conference. Please. Thank you. Thank you so much. Have a great day. Bye-bye. Stay safe. Take care. Bye-bye.